The log-normal distribution is very popular in structural reliability, not only because the log-normal is the limiting form of the product of a number of independent random variables, just like the normal is the limiting form of the sum, but unlike the normal, the log-normal distribution is defined only for positive values, and for quantities like yield strength and compressive strength, it's the natural choice. So if x is normally distributed, exponential of x is log normal. So that's how the two are related. And it's useful to be able to relate the moments of one with the other. Mean of x and sigma of x, and mean of y and sigma of y, or equivalently the COV of y, they are related as you see here, and it will be good to remember them when we will solve problems involving the log-normal distribution. And that is because the CDF of the log-normal y requires the normal distribution function, and which in turn requires the mean and sigma of the underlying x. Let's solve a problem and it will be clear. So here we have a fatigue life problem, and let's just spend a minute to read it and then we'll start solving. So S is the log-normal stress amplitude, and given its mean and COV, we can find the sigma and mu of the underlying log of S, and then we can invert the Basquian model and write the random fatigue life, the number of cycles n, in terms of S. And because S is log normal, it's easy to see that n is log normal as well, because the normal distribution, the normal family, is closed under linear transformations. If we take log on both sides, it becomes clear that log of n is log of c minus m times log of s, and c and m are constants. So we can find the mean and standard deviation of log n in terms of Cm and the mean and standard deviation of log s, and here are the values. And once we have the mean and standard deviation of log of n, we can find the corresponding values for n, and that's exactly what we do next. So what's required is the mean of n, and we can plug in the values, and the mean of n is about 43 million cycles. And to answer part B, we just go back to the definition of the CDF. So P of n less than or equal to 10 million comes down to the normal CDF evaluated at what you see on the screen, and the answer is about 0.0026, that the joint will fail before 10 million cycles.